My name is Cassie from Peplink marketing team. So thanks for joining our PCE training today. This training will have a 3-session. Today is the first session. And we invited our Germany VAD partners. He is our certified trainer, Dennis, to be our trainer or speaker for today's webinar. Thanks for your time today, Dennis. So I now pass the time to you. Yeah, please share the slide and share your knowledge with the community. Thank you.
So thank you, Cassie. Yeah, my name is Dennis. I'm the technical sales engineer from Vital, Germany, the distributor for Peplink in Europe. So, and I'm happy to bring you a little bit more with the new PCE 4.0 training. And I hope you will learn a lot. And in the next sessions, you learn some more stuff. So it's really a lot to do. And yeah, if you have any questions, feel free to ask.
Yeah, give me one remark is today we will cover a lot of things, but this is not, we will not cover 100% or everything. So we will share with you the slide. The slide will have more supplementary knowledge on that. So today we will just go through some important things, and then we'll share with you about the examination technique or things. In case during the examination, you can refer to our slide for revision and also for finding the answer. So this is the key. If you have any questions, then please mark down here. And then in the third session, after 2 weeks, we will have Stone be our trainer to answer all of the additional questions together. So sorry, Dennis, you can go on now.
No problem. So then let's start. I think Peplink is known from everybody because it's a certified engineer meeting. So I think I don't need to talk about the basics. Yeah, what do we do today? We look about the SD-WAN, the SpeedFusion configuration, some products, features, and so on. But the most important thing, I think, is what have we to do the Peplink certified engineer? What is it? We have 2 certification tracks. One is the technical support engineer and the sales engineer, so PCE and Peplink certified sales specialist. For the Peplink certified engineer, we need a lot of technical know-how. Peplink has created additional paths for training, so this will be aimed at certain vertical markets. All candidates wanted to gain certification in particular market track must be already taken and passed the PCE. You are not limited on the amount of certifications you can undertake. A lot of candidates currently hold both the PCE and the PCSS certification. You can do both the PCE and the PCSS. The first training track under the PCE is for the maritime market. And what we do today is the PCE overall, yeah? Not in the verticals. So we have to learn everything. So yeah, let's go on. What have we do in the to get the PCE? We do multiple choice exam. We have to understand nearly everything about Peplink. We need to know something about SD-WAN, about the Peplink VPN SpeedFusion technology, about the hardware from Peplink, Pepwave, and PepSim. We need to know about the cloud-based networking, InControl, Fusion Hub, the private hosted InControl, and so on. You have to do 50 questions and you have 100 minutes time. So 2 minutes for each question. This will hold 2 years and you have to know 70%. So I think it's doable. Normally it costs $150 or euros. And as I know, if you are in this session, it's for free for you. So how can we do that? At first, you have to visit the training website on training.peplink.com. You register there, and then you can enter the course. After that, you do the certification exam. And yeah, if you begin it, you have 100 minutes time to complete it. So prepare you well, and then it's really doable. Yeah, here are some slides how to do it exactly. I think I don't need to clarify how to log in. What do you have to learn to do a positive test? You have to look in the training documentations, the webinars from the old webinars, and I think in the future, this webinar is also on the list. You need the Peplink website, you need the release notes, maybe the latest and maybe some older. And you need the forum, and yeah, if you have access to everything, yeah, you have the big chance to do it. Here are some example tests from the mock tests, some example questions, like what are the routing protocols supported by the Balance and Max family? How can we find the solution here? At first, we have to look in the Peplink manual, then we find the routing protocols and we find the right answer. So in this example, A, D, and E was right. But the most important is not the right answer. The important things here is how to find the right answer. You don't need to know everything. It's enough if you know where you find it. Also, you can find it on the Peplink website. Here in the section networking, you also find the right answer. So some different ways to find it. The next question from the mock test is, what is the sizing criteria to choose the right fusion hub? Yeah, also easy. I would look on the website, and then we find the difference from the fusion hub, and you see, yeah, number A was correct. So the Peplink homepage gives us the solution here. In which situation is captive portal applied to an SSID instead of a VLAN? Huh? Nice questions. This would be a question for the Peplink forum. And in the Peplink forum, you find a lot of answers here. And after you find it, you also know what is right. Here in this example, choose the statements that is correct. Describe how the outbound policy rules are executed. You have to choose two. So the next is have a look in the forum. And in the forum, you find the presentations. And in this presentation from Peplink, you will find the correct answer for here that you have to enable the expert mode, for example. So this was important that you know you have to look in different spaces and different locations to find the answers for the questions. Sometimes they are really hard to understand, especially if you're not a native speaker like us in Germany. But if you look in the forum and all the slides and presentations, then it's really good to do everything and find everything. So the next thing is the Peplink core technologies like InControl and SpeedFusion, of course, or the enterprise features. Let's start with SpeedFusions. What do we need to do SpeedFusion? We need at least 2 Peplink routers, two routers which can do SpeedFusion or PepVPN. The difference we see later. And if we have 2 devices, then we can set up, of course, a PepVPN with a SpeedFusion tunnel or something else. And we have different configuration types like point-to-point, meshed. But I think the most is easy for you. You know, I think the most things by yourself. The security is a big thing, especially in the moment. How is the security working with Peplink? Is it really secure or is it not? it is. We have Peplink is using a 256-bit AES encryption. So on every single line, they will do a key exchange with Diffie-Hellman protocols and will encrypt each line with an own key. So as more lines as you have, more LTE lines or cable lines or something else, as more the security will raise up. And the example on the right side, you see a Peplink router with 4 WAN connections, and on the other side, a router with 3 WAN connections. So we have 12 sets of encryption keys. We have 12 AES encrypted lines. If someone will do a man-in-the-middle attack here, he can't find everything. He can find maybe fragmented encrypted informations. And even if someone can hack the 256-bit security level, which is hard, then he can't do anything with that because these are only some fragments in the wrong order. So he has nothing. So if you want to do a really secure installation, please use as much lines as you have. But to do this, you have to open maybe some firewall ports. In some regions, UDP, for example, is blocked from the government or from some providers, then you have to change it. Or if you are behind a firewall, it's important that you have to open the typical ports for SpeedFusion. The typical ports every PCE has to know in sleep is TCP port 32015 and UDP 4500. These are the most important ports. Every PCE has to know it while you're sleeping. If you do more tunnels with subtunnels and something else, it will count up. Or if you're using IPsec or L2TP, then maybe 4500 is occupied, then you have to use the next port. Or SpeedFusion will change to UDP 32015 automatically. But I can recommend to do a small range and to open the firewall at first. If you see SpeedFusion is not working, the first look is about the TCP and UDP ports. Of course, you can use custom ports if needed. Then it's not a standard installation, but you can do it. That's really, really interesting. And if you're using multiple tunnels, as I said, then the UDP ports will count up. So it's 4500 for the first tunnel and 4501 for the second tunnel. So on the headquarter where the Fusion Hub is, for example, you have to give up a range in the firewall that everything will work. The next we see is, as I said, what is the difference between PEP VPN and the other things? The basic of all is PEP VPN. PEP VPN is like an IPsec connection, but with the magic of Peplink, it's easier to do and it's much better. We see it later. And you have much more features on it. Every Peplink device, every Peplink router can do PEP VPN, or even the Surf Soho. The first step we can add is hot failover. So hot failover means we can switch the lines without interruption of the PEP VPN. The next is WAN smoothing and forward error correction. So we can duplicate or receive our protocols or packets if we have some loss on the lines with a bad internet connection or something else, but we see it later in detail. And the top of the pyramid is the bandwidth bonding. So with the bandwidth bonding, we can combine all our lines to a bigger bandwidth, more security, and that's a install and forget solution. So if we do bandwidth bonding, then everything will be connected every time. and it's nearly not possible to interrupt this. You have to power off your router. So what is the difference? With bandwidth bonding, we can combine the speed and bandwidth of multiple WAN connections or cellular connections. So we do it on a packet level. It means we do our TCP stream and put it in some smaller pieces and send it on all other lines, and we'll build it together on the other side of the tunnel. With the bandwidth overflow, we can make one line full and then we use the other line. So we can use all lines we have with nearly 100%, but it's not completely bonded then. With WAN smoothing, as I said, we can create a jitter-free and uninterrupted connections. It's really important for the media broadcasting area. There you need the WAN smoothing. And in the hot failover, if one line goes down, it will switch automatically to the other line, and your session is always online. So in the detail here, you see the hot failover is for small offices, long distance Ethernet, retail connectivity. Sometimes if you do a switch in the hot failover, you have to press F5, for example, that your website is loading again because you changed your IP address and something else, but you are online, but not uninterruptible, or maybe sometimes not interruptible. You have to choose really, do I need hot failover or do I need some other stuff? But it's really reliable, and the bandwidth will not be increased. So how it works, as I said, if some line goes down, it will switch to another line automatically. You don't need to do anything. It will work really fine. And in this example, cellular is in standby. If MPLS and DSL goes down, cellular will wake up and the data will go through the cellular automatically without any manual doing from the administrator. The WAN smoothing, as I said, is really important for voice over IP, video conferencing, TV and radio broadcasts. For TV, it's really easy to explain. If you do a video broadcast and you see packet loss, you will see it in the picture. The picture is stocking. You see some brick wall effects in the pictures. That's not nice. And if you do WAN smoothing, we can duplicate or triplicate or as many lines as I have the packets, and then the first packet what received on the master side, this will be taken and the other packets will be removed. So we duplicate or triplicate our usage on the line. It will slower, of course, but it will be much more reliable. It's really important to do that. Sometimes I don't need the big bandwidth, but I need every data packet. Then WAN smoothing is your choice. Yeah, I explained it on the first picture. Of course, you can duplicate it with a medium, and then you have every data packet on double side. So we have zero interruption and no delay. It will be an absolutely stable connections. But the bandwidth consumption is at least 2 times of the original traffic. If you switch to medium, it's 3 times, or high, it's 4 times. And if you switch it to maximum, then it will be as many lines as you have. Also, if you have only one line, you can use WAN smoothing and send on the same line every data package doubles. So this is important. If you have a router or internet connection with a lot of packet loss, then it's better for me to send everything doubles before I wait until the acknowledged bit will be received, or in UDP traffic, I will never notice that the traffics don't receive my destination. So this means if you have like this road with a lot of holes in there, advanced smoothing, make it really smooth, then you can drive without any interruption or any problems. And yeah, so this is really good to know. The other way that we can use is the forward error correction. The forward error correction is like doing a RAID system with a hard disk. You have parity bits, and you can with these reserve packets, like the parity bits on the RAID on the hard disk, you can interpolate the packets they are lost on the line. This is really cool for a one-way video connection. For two ways, you have to use advanced smoothing, but on the one way, it's a really cool thing to do that. It's like SRT a little bit in the video streaming, but this is for network protocol, so you can use it not only for video files, you can use it for everything. This is really nice, and it has a little bit less bandwidth consumption. So you have 13% in the normal setting and I think 26% in the high settings. So for smaller bandwidth, it's the way to go. You have to choose it, or you have to test it. If it's enough, then it's good, and if it's not enough, you have to go with bandwidth with advanced smoothing. If we use bandwidth bonding, that's what I said. It's install and forget solution. You can replace, e.g., MPLS for that because you have more bandwidth. It's cheaper. It's reliable, and it's always online. It's working hand in hand with hot failover and PAP VPN. You can build a fat tunnel pipe with all connections you have. You can use it as a multi-WAN line, and it provides us a single super fast tunnel. So this is what you cannot do with IPsec. You need SpeedFusion for that because you build up a single VPN connection over every line, but it looks like one really big pipe. That's really cool to do. Also, you can do is a layer 2 tunneling over this. With the layer 2, it's like a really long network cable. You can, for example, be in New Zealand and the other side is in Germany, and you build a layer 2 connection and you have the same local IP addresses, and yeah, it's like you are in the same network without any routing, without any hops, and that's a really cool solution you can do with that. So it's easy. It's easy, scalable, and if you need more bandwidth, yeah, then plug in a new line and plug it in the tunnel, and that's it. That's really, really, really cool. Yeah. On the next slide, it's the same I talked about, like every time. You can establish a tunnel over all active links, and as you can see here, the data package are on parallel on each line and will be plugged together and ordered in the right direction on the destination, and the user will receive the package as the camera has sent in this picture. So it's really nearly uninterruptible. Also, if there's a hot failover while we transmit data, we don't get it. It will be automatically sent again on the other line, and that's it. So you can set it to check the line extremely, then it will check all lines within sub-seconds, and that's really nice. So it's fast. But if we use SpeedFusion, we have a little bit of overhead, of course. A normal IPsec has an overhead from 16%. And in this case, you see the iMix. We have to add some special headers on it, some bytes that the header will be packed on the header of the packets, because we have to reorder the packets on the other side. We have to know which packet has which number, and that's not basic in any VPN connection, though that's why we have a little bit more overhead. It means the data will be encapsulated in a special Peplink UDP stream. And in this UDP stream, these header is additional 80 bytes. So this means we have an overhead from about 19%, and with IPsec we have 14.6% overhead. So we have only 4.4 more overhead compared to IPsec, but with all the features we have from the SpeedFusion tunnel. So it is really the way to go. How can we calculate it? We have a 10 download to make upload line to two pieces of that, and on the other side we have 100 Mbits synchron line. So it does not mean you have 20 megabits download and 4 megabits upload. It means you have nearly the 20%, 19%. So you have 16 megabit upload and 13 megabits, 60 megabits download and 3 megabits upload in the overall. And that's really cool. So you have to calculate it sometimes. Maybe it's good to bond it, and if the lines are too different, you make the lines slower with this standard bonding setting. Then if you do it otherwise, you have to change it to dynamic weighted bonding. Then you also can generate more bandwidth with different lines. So if the lines are really different, please choose a dynamic weighted bonding. To make it as secure as you can do, you have to use at least 2 different ISPs, maybe also different services like cellular, cable connection, fiber connection. Then you are safe if someone is digging your cable out of the floor. Then you are always online. If we compare that to an MPLS line, we will save really a lot of money. I don't know how the costs for MPLS are in other countries. In Germany, MPLS is really, really expensive. So if you have a big company and they're using MPLS, many companies can save so much money that all Peplink hardware is included in the price in lower than 1 year. So in 10 months, you have spared so much money that you nearly earn money with because you're using Peplink. That's really cool. Huh? What is the difference to IPsec? Many of our other guys using IPsec, and they don't trust SpeedFusion or Peplink because they don't know it. With IPsec, yeah, we have also 256-bit AES encryption, but that's the same. The only thing what is same. And IPsec, it's not really easy to install or to look if someone is not working as expected. And if you want to do it encrypted over more than 2 or 3 locations, you need to be a really hard expert in IPsec doing. And if you want to do a hot failover, then feel free, but I don't want to do it anymore because I know Peplink now. With Peplink, you can do it in a few seconds. So it's with the PepVPN, it's easy. It's also for dynamic IP environments. If you don't have a fixed IP address, yeah, it doesn't care. We can do it. The hot failover is easy, and the WAN smoothing, as we talked about, really okay. And of course, the bandwidth bonding is the king of all. So I said it's easy to do. How to do it? We have two ways. One way, the easiest way, is to do it with InControl. If we open InControl, we click on PepVPN, set on configuration, and then we can do a configuration over multiple groups or not managed InControl managed devices or for the whole group. We can choose between fully meshed, hub and spoke, point to point, and yeah, that's it. If we configure it, then we say, okay, configuration, add profile. In this example, we want to do a star. We choose our devices, which IP address. The IP address will be filled in automatically because InControl knows the IP address. Sometimes you can see more than one IP address. If it's an IP address you can reach from the outside, it's perfect. If it's an IP address from the inside, because the device, for example, is behind a firewall, please remove this IP address. And then choose your endpoint device, click on next, and that's it. If you do it with fully meshed, you can choose in the first step multiple devices, and then you build a connection from each device to each other. So you build it, fully meshed. And on point to point, it's for two devices. So device A to device B. In this, we can set some different things. We have here, for example, the disaster recovery. Disaster recovery means what happens if this device is not available because the line is down, the device is down. However, you can set a disaster hub that the tunnel will be built to the other device if this is down. Yeah. So it means you have to be always online, also if someone happens. You can set the link and the WAN settings. If you click on the advanced link settings, you can choose the codes for the different lines. You can choose, will it be used only to which connection it will be used? And in the advanced WAN settings, you can set, do I want to do it in which priority? And do I want to use it only for upstream, downstream, or both? Maybe some connections are really good for downstream, but bad for upstream. Then you can use it only for downstream. And you can choose also the remote WAN, because sometimes it could be possible that you can reach something over an external line, something over an internal line. Then you can choose it and set up like as you need it. So it's very flexible to do everything as you need. If you're ready, please don't make the mistake I do every day. I forget to click on save. So please click on save. If you do that, this configuration will be saved on the devices and the tunnel will be set up. If it's saved, you see it on the green lines that the tunnel is online and everything is fine. So we can see it in the normal location, the logical location. So you see the balloons, that everything is online, the devices are online, and the tunnel is online. Or you can see it in the map, like GPS based. You can see really where are the devices located. Is everything green and everything fine as expected? So it's also included monitoring system for VPN tunnels. If you do it locally, you have to know one more thing. It's the local ID and the remote ID. The local ID of your device is the remote ID on the other device. So local ID will be needed on the other device, and and otherwise. So at first you can save it or you can give a name. It's up to you. Then you click on new profile. You can click on the profile and set everything. It's identical to the settings in the InControl. And after you saved it, it's ready. And if you want to send all the traffic up in the VPN tunnel. This is really important. It's like routing from 0.0.0.0 over VPN. Then you select this the sign and send all traffic to, choose your profile name, and then you have to enter 2 DNS servers. In this example, these are the Google DNS servers, and that's it. On the left side, you see the link failure detection time. That's also really important. How fast should the system monitor all your available lines? In standard, it's about 15 seconds. And if you need more, example for video streaming, you can set it to extreme. Then it's in some milliseconds, it will check every line. Of course, it takes a little bit more bandwidth, but it's more reliable. If we need to change the handshake port, please click on the question mark on the help icon, click on the here, and then you can set a custom port. By default, it's TCP 32015. Of course, some slides before I said you had to know this in your dreams. The link failure detection time, okay, I was too fast. Yeah. So here we can see the local configuration from the PAP VPN. At first, we set a profile name. Please choose a name that you know what you're doing here. And the remote ID, you have to enter the local ID of the other peer. And the pre-shared key is a key of your choice. So you can write something like, I don't know what to enter here. And if you write it on both sides, it's the same password. It's like a password, but it needs to be the same password on both sides. The remote IP address, you only need on one side. Normally, you do it on the side for cellular lines or something else, not on the headquarters side. If you don't have a fixed IP address on your other side, you can also write a name like the DNS name or something else. Then you can see you can choose here WAN smoothing, forward error correction, and so on. And you can set the WAN connection priority. So, for example, we say, okay, we are on a boat and we need cellular connections with highest priority, and the WAN connection for satellite is the lower connect priority. Then we set it to priority 2, for example. The NAT mode. If we select the NAT mode, yeah, I don't need to read the whole text, but you can activate NAT for this device in this tunnel. That, yeah, it has to be, the network address translation will be enabled in the tunnel. The coasts is really interesting. If we want to set up different coasts, we can do really cool scenarios. It's like in the rapid spanning tree, but this is not a rapid spanning tree, it's OSPF. And the OSPF will go over the cheapest way. So in this example, we see there's a coast from 10, between B and C is also a coast of 10, and the C to A, it's a cost of 30. So if C wants to send data from C to A, it will go over B to A, because the way from C to B is 10, from B to A is 10, though it costs completely 20, and the shortest way will be cost 30. So it will go to the cheapest way with 20. With this coast, you can set up different rules to configure where that data has to go. Here we can set up in the tunnel. The other was out of the tunnel. The data port is in the tunnel. We can specify the UDP port away from 4500 or 32015. If this port EG is used from other stuff. If you are in a country where UDP is not allowed or is blocked, or maybe the company doesn't want to use UDP, you also can change it to TCP. I don't know how long it's written as experimental. I know it will work. We have done it a lot of times and it's working really, really good. Of course, TCP needs always the acknowledge bit. UDP doesn't need it. So TCP is maybe a little bit slower than UDP. But it's important to know where to set this and that it's possible to set this. The packet fragmentation. It's normally we don't need it, but sometimes we do. Some devices, or we have to start earlier. In the SpeedFusion, the MTU size is 1360. Some devices have a hard set MTU size of maybe 1400. If it's hard set, then it will be fragmented. So we can set the DF flag, the don't fragment flag, or we don't want to do that. So you have to choose, do we need this? Do we want to fragment packets or not? That's the most important thing. Normally you don't need it, but it's interesting to know that we have it. For example, if you don't want to fragment the bits, or then you can't send packages which are bigger. If you do an SRT stream, for example, and you don't set this, or you have set this, the SRT won't go through it, because SRT stream is bigger from the MTU size. So then you have to fragment it. Then you have to set it to always. You don't need the DF flag. Let's have a look onto InControl. We have two management options. First of it, it's the InControl. Everybody knows it's InControl2.peplink.com. It's the Peplink hosted InControl. If you set up an organization, you are the administrator, the organization administrator. In this organization, you can set up a lot of group admins. That means you can, for example, if you have your own InControl, you can say, okay, customer A is group A and the admins are the IT guys of this company. In group B, the admins are the IT guys of this and something else. You can enter every group. And in these groups, there are the devices. So you have the group level, the organization level, and the device level. And you can configure different things in the different organization levels or InControl levels. If you have a private hosted InControl, it's nearly the same, but you have one step before. You have the MSP administrator. The MSP administrator, so the managed service provider administrator who's hosting this InControl, also has access to all organizations. And he has to allow, for example, the devices, the firmwares, and something else. In the Peplink hosted, Peplink is doing that for you. But you can use it for your own installation if needed. So we see we have a lot of features we can do with InControl, like the bulk configurator, with zero-touch configuration. So we can use for zero-touch configuration, we can use the bulk configurator. The remote device IP configuration, we can do it over the Excel file, for example, and set the IP addresses. We can set outbound policy for every device, the central firewall configuration. This is really, really interesting. And in the time of, in this actual time in Germany, many companies are scared or afraid because they don't want to be hacked from some bad countries. And so you can block some countries country-based IP addresses. So you can say, okay, IP addresses from country A, I don't want to get in my network. I can block them inbound and outbound completely. We can do the centralized firmware management. That means we can do firmware updates from InControl side. We can update complete groups. We can do it per geofencing. We can do it by time or something else. We can set SSIDs remotely. And of course, one of the cool features is the captive portal. We can do it easy customized captive portal for all devices. Let's go into the details. What is an outbound policy? An outbound policy means we have to route the traffic, the device, or the way of the traffic some devices has to send. In this example, we see some different colors. You can see this computer will go out over WAN 1, the mobile will go out over WAN 2, and the camera will go out over WAN 3. Why is this, or why are the devices choosing this way? Because we can configure it. This is really important. You use it nearly every day. The 8 outbound load balancing algorithms. So at first we start with the outbound policies in the basic. In the outbound policies, we can add a custom rule. We can, if we set them, we can drag and drop them into top or in the bottom. Always the rules on the top will be the first rules we will be chosen, and on the bottom these are the last rules. If you don't need some rules, you can click on the X and it will be deleted. So let's have a look in the different outbound policies. The weighted balance. It means it assigns more traffic to a faster link or less traffic to a connection with a bandwidth cap. You can set a weight on the scale of for each connection, and outgoing traffic will be proportionally distributed according to the specified ratio. This means you can send a percentage line for each carrier. You can set example in this example of a Peplink balance 310. You can set WAN 1 to 10, WAN 2 to 10, and WAN 3 to 5. This means the total weight is 25, and it means, oops, sorry, too fast. This means WAN 1 is 40%, WAN 2 is 40%, and WAN 3 is 20%. And then everything will be routed, will be filled up to the different usage. Here you can see this example, yeah? So it's really easy with those points to set up to the left or to the right, and then you can set the different weights of the WAN links, and this will be used like this. The priority rule, this is what I use mostly. With this, there you can route the traffic to the preferred link as long it is available. So it means if we set the carrier 1 with the highest priority, we will send every traffic over carrier 1. If carrier 1 goes down, all traffic will be sent over carrier 2. If carrier 1 will come back after it will be repaired, then the traffic will go back to the carrier 1. This feature is really old. I think it's starting from firmware 5.2 or something else. It's really a nice feature, and it will be used really often. You can also set in the priority rules the VPN connections. So there's a question: do we need to request for recording? Okay, I think it was to this point. No, it was not. So you can also set the VPN into this priority rule. This means you can set, for example, different VPN connections and set the outbound policy, go please everything over the VPN headquarter 1, and if VPN headquarter 1 is not available, use the VPN headquarter 2. And if this is also not available, please don't use the VPN, then we want to go out over our WAN lines. And that's really cool to set up. So if we do it in an enforced connection, that means we want to fix some traffic. We don't want to set it maybe for every traffic, but maybe for some special traffic or from special IP addresses. We can say, okay, all my traffic from the camera should always go out over carrier 1, and the others doesn't care. You can decide which traffic has to go out on which line. Then you can say, choose it like that. You can also say, okay, this traffic, maybe you have some internal traffic from your data system, like your warehouse system, then you want to have this data unencrypted in the internet, and you can say from this devices, everything has to be sent over the VPN and nothing else. Or in this example, it's this SMTP traffic to a specific WAN link, because maybe the mail server is only available on this WAN line. So it means with priority and enforced, with this both, you can also use the VPN connection, and the others not. So in the others, you have only the physical WAN lines. Yeah, this is good to know. Only VPN, only for priority and enforced, and the others you can only choose the normal WAN lines. For example, the overflow. What is the overflow? The overflow means, okay, let's fill up carrier 1 at first. If carrier 1 has nearly 100% of bandwidth congested, then we switch back to carrier 2. We send the next traffic to carrier 2, and if this has 100%, we go to carrier 3, and so on. So we can fill up the lines one after the other. Maybe you have some different contracts where you have to pay for each gigabyte. It should be possible that something like this is existing. The lowest latency is also really important. With the lowest latency connection, you send always this traffic to this line what has the lowest latency into the internet. So to the Google server, for example, we can measure with carrier 1. In this example, we have 40 milliseconds to Google, and with carrier 2 we have 30, and with carrier 3 we have only 20 milliseconds. So carrier 3 is the fastest, so every traffic will be sent over carrier 3. And it's a predefined time interval where the speed checks will be done from Peplink automatically, and the fastest line will be chosen. But it's the fastest line to the internet. Now we have 3 different outbound policies. Overflow, it means overflow, let's fill up one line. Lowest latency, we also had on the last page. It means, okay, we go to the fastest internet connection. And least used means we want to use every line like a fair use policy. Then please split your data and we say, okay, WAN 3 has not enough bandwidth consumption, then we send the rest to, on WAN 3 that, yeah, it was least used. So yeah, it's the link with the most available bandwidth. Maybe you have a contract with like a cellular contract and you have only 100 gigabyte or 50 gigabyte on each cellular line, then it's important to fill up each basic contract bandwidth before we have to pay extra money. So there's a question to this regarding overflow. If you defined a speed for one WAN, let's say 100 megabits, and for any reason the provider gives 50 megabits, will the system detect connection of the WAN and 50 megabits related to the WAN speed? If you set the WAN speed manually, we don't send it faster than this. If only 50 megabits is available, then we use only 50 megabits. So if we aggregate two WAN connections, then we can't use this, because if we aggregate two WAN connections to a bandwidth bonding, then we can have to choose between priority and enforced, because in the tunnel we cannot use the lowest latency in this time. Maybe it's in a future release, I don't know. So the persistence connection means we want to prevent the traffic from slowing down. So we can say, okay, this traffic will always be on this line, and it should be a persistent connection, of course. And the name says everything to that, yeah. You also can choose it by drag and drop, and can set the distribution weight here. And of course, it means if you have a HTTPS session or something where you have a special ID, you don't want to change your line in the like in hot failover every time. Then we need to do it persistence. And we say, okay, we have one connection maybe to my Google Mail account, and if I have to change, if the Peplink will change me from 1.1 to 1.2, my IP address will change. Then I have to press F5 that I'm online again. And then for that, we need to do it persistently, if possible. And you can say by destination or by source, of course. And that's also sometimes really important, that the connections will, that you have a seamless connection. Everything is working as expected. So fastest response time is really interesting. It's like the lowest latency, but one step more. The lowest latency is only into the internet, and the fastest response time is the complete way to our destination. So it could be possible that I go over carrier 3 in this example. We go maybe with a oversea cable, and then from the internet to our destination, our headquarter, it's too slow. And that means we can measure it every hop and can select always the fastest line from local network to our destination. So in this example, we want to restrict an IPsec traffic to WAN 1. You see, the name is a name where you can know what you have done there. So please always take good names. To configure the Peplink balance to restrict IPsec VPN traffic to WAN 1, add the following service enforced rules. At first, we specify the rule. We do a service name. We say, okay, any source to any destination. because we don't care the destination. Maybe we can set the destination IP address, but maybe not. And we say, okay, our point to know that this is a VPN connection, it is UDP port 500. So we select port UDP 500 to do that. And then we say, okay, it should be an enforced rule, and we want to send it over WAN 1. This means if I have a traffic with port 500, every time WAN 1 will be used. On the right side, it's the same. We do it for port 4500. With these 2 ports, UDP will be routed over WAN 1. Why do you do 2 ports? Easy, because you need to do an IPsec VPN with NAT-T. That requires UDP ports 500 and 4500. So if you have to route the traffic, you have to know what you have to route. Yeah. And in this event, WAN 1 will go down. The specified traffic will simply be dropped rather than routed via the other WAN links. So you have really to decide, is this the right solution? So the expert mode in the outbound policies. Feel free and use the question mark. There are not only help functions. There are many different settings. They are like the expert mode. The expert mode is available for advanced users. So click on the test balloon, as I said, and click on turn on expert mode. Under the expert mode, a new special rule, SpeedFusion routes, is displayed on the custom rules tab. This means you can say these rules are my OSPF, BGP, and PEP-VPN routes. Routes Peplink does automatically. And if you enable the expert modes, you can set some rules that are more important than this SpeedFusion rules. But be careful there. By default, this bar is on the top of all custom rules. This means traffic for remote VPN subnets will be routed to its corresponding VPN peer. You can create custom priority or enforced rules and move them above the bar to override the SpeedFusion routes. But don't forget, if you disable the expert mode, all rules above the SpeedFusion bar will be deleted. So it's a nice setting, the drop-in mode. What is a drop-in mode? Do we need it? Sometimes. So the drop-in mode allows Peplink, Balance, or also Max devices to be deployed in a network without incurring any configuration changes to existing network devices. It simplifies the installation of a balance to an existing network by transparently and seamlessly working with the routers and firewalls. It means you are arriving to a company with your Peplink, and they have a firewall, they have some routers, and they say, yeah, okay, I need a second internet service provider, but you are not allowed to change IP addresses of my firewall and my ISP router, for example. Then you have a big problem normally. But if with Peplink's drop-in mode, you can do it with only a short interruption. The short interruption is to plug out the cable and plug it into the Peplink router. So only a few seconds. In phase 1, you have to insert the Peplink into the existing environment. Suppose you have a migration plan similar to the following environment. Currently, you have a default router with a default gateway 210.10.10.1 connected to ISP1. And the firewall 210.10.10.10 is protecting your users to the trusted LAN. We will be installing the Peplink transparently between router and firewall And then we will add the second ISP connections to the network. So we have the router with the .1 on the end. We have the firewall with the 10, and the default gateway of the firewall is the 1. That's normally a problem for us if you want to go with the firewall out to ISP2, because the gateway is a .1. Our Peplink, we gave them with the IP address .5 on the end for WAN 1, and we set the LAN bridge. The WAN 1 subnet is 255, 255, 255, 240. First, we go to network interfaces LAN, and then we can set our IP addresses, and we have enabled the drop-in mode. We also set here the default WAN gateway. That means the Peplink has to know what is the default gateway for the other devices. Notice the ARP table has to be resetted from some devices, because the ARP in the ARP cache of the firewall, maybe it is known that the .1 is the ISP router, but in the future the .1 is the Peplink router, because the Peplink only simulates for the firewall that it is the .1, but it isn't the .1. It's the .1 only for the site to the firewall. So on this side, it looks like it is the .1. On the right side, it is not the .1. Though maybe you have to reboot the device or have to clear the ARP cache. And after you have done it, you can set the additional WAN connection. So we say WAN 2, we have to enable NAT for that. And that's it. Then our device is installed, and we have done that before it was a direct connection from ISP1 to the SD switch or the firewall. And in the future, we can have multiple lines. There's a question, what I have 3 ISP lines, ABC, my persistent wait will be prior ISP. A with ratio of 10:99 is a way that I could let the ISP B to take the persistence load. Why do you want to do it with this rule? Maybe you choose a priority outbound rule. Maybe it's better for you, and you say, okay, then we do it with the priority rules. I think you have to choose another outbound rule that could be better. So let's go forward with the drop-in mode. After we have inbound load balancing rules, or we have to create maybe inbound load balancing rules in our drop-in mode. Once the drop-in mode with multiple LAN links is successfully set up, we can proceed with inbound load balancing. This will allow the internal servers to be publicly accessible. So this task assumes that you already have a good understanding of drop-in mode. If not, please read the guide of the drop-in mode in the Peplink forum before you proceed further. In our scenario, we will use an example throughout this node. Suppose you currently have a network similar to the following: Peplink balance installed and connected to 3 ISPs using drop-in mode. Static IP address ranges, subnet from the ISPs. A firewall is protecting your trusted LAN. Host and server on the trusted LANs are using private IP addresses. We have enabled NAT on WAN 2 and 3 to masquerade the IP address of ISP A to achieve inbound load balancing. So in our example, we have router A with the 210 network with default gateway .1 on the end. The ISP2 is a 22.2.2, always with the .1 as gateway, and ISP3 is 33.3.3. So how to set up the inbound load balancing in the drop-in mode. We can do it in the additional public IP settings. So network interfaces WAN settings, and then we can select the WAN port, and we can give them the additional IP addresses. This IP addresses could be the IP addresses of our servers, or the IP address we have from the provider, and then the Peplink device will listen to this IP addresses as well. It's necessary that you have this IP addresses, yeah. And then we can define the inbound servers. Then we can set, in this example, our mail servers. After that, we can go to services and can select the WAN connections where this service should be available. So we have the SMTP mail 1 in this example with WAN 2 over WAN 2 and WAN 3, all these IP addresses, and our mail server. This means from WAN 2 and WAN 3, we have set it up. All this traffic will be routed to our web server. Our web server now has WAN IP1, WAN IP2, and WAN 3 IP. It has like an external IP and is available from the outside. So we can set up here a built-in DNS drop-in mode. That means you can delegate domains, name servers, SOA records, e.g. for here my company or my Peplink.com to the Peplink balance WAN IP addresses. You can also act as a generic DNS server for hosting an a C name, an MX record, TXT, or NS records. The Peplink balance can perform in these two methods, either in the drop-in mode or not in the drop-in mode. It's not need to do this in the drop-in mode, yeah. And PTR records are created along with the A records to point to custom IPs. If you create an A record in mydomain.com pointing to an 11.22.33.44, then a PTR record will be pointed 44.33 blah 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 .in IP address APA pointing to mydomain.com will be also created. When there's a multiple host names pointing to the same IP address, only the PTR record for the IP address will be created. Inbound load balancing is configured via the DNS records configured within Peplink balance or the external DNS records with an authoritative DNS server. So in this illustration, you can see it will be available if you do a request for an NS lookup for mypeplink.com. You will receive this 3 IP addresses with the .5 on the end for mypeplink.com, for example. And that's a really cool solution to do it by yourself. There's a question: does Peplink support SD-WAN? Of course, Peplink is a perfect SD-WAN system. You see this DNS settings. You can do into network inbound access DNS settings. Then you can set all these settings also with priorities for different WANs. And you can select the WAN interfaces and the IP addresses you will set for this DNS server. The SOA and NS records, it's also in the DNS settings. You can map 1.1.1.2 interface to the name servers. No? So it's easy. You can set the time to live and something else. And, you can set it easily here. In this example, we see how to configure the priorities. It's like everything in Peplink, a drop-down menu, and select the priority you need. Of course, here the mobile internet we only use in the lowest priority. But if you do it as an inbound DNS connection with a mobile internet, don't forget you need to have a SIM card where NAT is disabled or where it's allowed and possible to go from an external line to that. The record for the name servers, it's nearly the same. Type the host name, including the www, or if needed. No, if you only write mypeplink.com www will automatically associate it. And only the highlighted IP addresses in the list receive responses to a DNS query you select here. Multiple items in a list can be selected by holding the control button and clicking the items. In case a WAN link is down, the corresponding set of IP addresses will not be returned. However, the IP addresses in the custom IP field will be always returned. Don't forget to click on the save and apply these settings. So it's really nice if you have your servers internally and they have to be accessible over multiple lines. You have to be more secure, or you have an internet web shop and you're losing a lot of money. If one line is down, then you have to do it. It's a really cool feature and easy to set up with a Peplink. So 1 second, I have to drink a little bit of coffee. The DNS registration or the domain delegation, it's useful for users who want to delegate a subdomain to resolve and manage with Peplink balance. In order for the internet users to look up the host name, e.g. mypeplink.com, using the Peplink balance, you have to point NS records of it to the domain, e.g. mypeplink.com or here fuba.com. And you can bind this, I see bind 8 or 9, and these lines, the zones will be filled. A file of mypeplink.com will be shown. As you can see, the auto-rative DNS for fuba.com, these are the typical records for this. And you see also it's the WAN IP of the balance shown, and for the www we also can see it. So what happens if we do an NS lookup? We can see this is the balance IP address, and with an NS lookup for mycompany.com, we can receive the correct lines. And that's really cool. We see the default server at the balance, which gives me the answer, and my my IP address or my internet address will be the NS lookup will give me the right answer here. So the next very important thing in my eyes is to set the system in a HA mode, so high availability. We are using VRRP for that, so the virtual routing protocol. That means we have a 1.+1 backup. It enables the failover to occur if the master device shuts down. This requires a pair of Peplink devices operating in active standby mode. That means it's not an active cluster, it's an active passive cluster. When the master device is down, the slave device takes over and handles all of the LAN traffic. If you have some rules here, like some VPN tunnels here, it takes normally less than 10 seconds, and the first tunnels are holding on the slave device if the master device goes down. You can put out the power cable, the slave will be powered on immediately and will be act perfectly. It works very, very good. The Peplinks, but it has to be the same device, the same hardware revision, please. And it's also good if you have the same firmware on it. The Peplink balance series supports failover between two balance devices based on virtual router redundancy protocol. Periodic VRP advertisement packets are sent out from the master device to VRP specific IP multicast addresses. The slave device assumed the master device's responsibilities when these messages have not been heard from a predefined time interval. So it means it's like a heartbeat, yeah? A heartbeat or multicast, the devices are connected together, and if master does not hear anything, if the slave does not hear anything from the master, then it will be powered on. So let's have a look at this example. We have created a VRLP group. It's important because if you have multiple Peplink routers, then you can create multiple virtual routing groups. You have to set up a virtual IP address. The virtual IP address is the same for Peplink master and Peplink slave. And the LAN IP addresses from the devices are different from the virtual IP addresses. If you enter the virtual IP address in your browser, you will come on the web interface from the master, and everything is fine. If the master goes down, you enter this virtual IP address, you will enter the web interface of the slave device. Of course, you can enter the slave device directly by entering the slave IP addresses. If you want to set up a high availability environment, it's important to don't forget something. In this example, the SD switches has to be redundant. The firewall here in this example is a single point of failure, but maybe the customer will change it to a firewall cluster as well, that it's completely high available in this moment. The drop-in mode is not needed to do that, but you can do it. It's only an example here. Yeah? So again, if you set up the HA mode, the master will go down, for example, the slave will do its completely job. And if the master comes back, then the traffic will be switched back to the master. How to configure this? It's really, really easy. We go to network, MISC settings, high availability, then we can enter the group number. In this example is 20. I don't know why 20, but we can use it at 20. We say, what is the master and what is the slave? On the left is the master, right is the slave. If we have the slave, we enter the master serial number that we can see it's definitely this hardware we will use, and we will copy the complete configuration. So then we enter the virtual IP address, and that's it. If we click on save, both devices will be configured, and the configuration from the master will be copied to the slave. Then you can see on the slave device, there are some icons missing here in the top, and configuration sync is active. Why? Easy. I don't want to change something only on the slave. So the web admin is really locked. If I have to change something because, I don't know, the master device is burned in a fire or in water or something else, then you have to disable it. You can disable the sync, and then you can configure the master. But normally it is synced, and you should see this icon. If you can see this configuration sync is active, you know your high availability cluster is up and running. Normally, as I said, the configuration will be copied automatically, but you can do it manually. Go to System, Configuration of the master unit, click Download the active configuration or over InControl. Go to System Configuration on the slave, choose the configuration you exported in step 1, upload the configuration from the HA pair, and click on Upload. Before applying the changes, don't forget to change the IP LAN address and set it as a different one from the master, as the master unit has. So don't forget to go to network LAN of the slave unit and change the IP address. After that, save and to change the changes. And then go to network, high availability, change the preferred role from master to slave, and then save and apply. Don't apply it before you have done the other steps if you do it manually, the HA mode. So next step is internet bypass, internet traffic bypass. Not many persons know this, but it's a nice feature. Make the long story short, what can we do with it? We have in this example on LAN 3 and WAN 1, there you see it small, there's written LAN bypass on the hardware. If I connect a device on LAN 3 and an internet provider on WAN 1, everything will be routed on my Peplink. Okay, what happens if my Peplink dies? Then it's like a relay. WAN 3 will be directly connected to WAN 1, and we can go in the internet. This is really nice. In some locations we can need it, sometimes not. But it's important to know that we have this cool feature. For trains or something else, it could be really important that we can use it if some devices are crashing, or sometimes it's better don't using the Peplink than we are offline. So this available features available, I think, in the Peplink devices 580 and higher. It's a fault-tolerant feature that protects you in the event of a power outage. If the Peplink router doesn't have power, you can't use it. When it's used in the drop-in mode, such failure would be completely transparent to the network. In this example, WAN 1 and WAN 3 and LAN 1 are bridged together when the power runs out. But if you use it, HA features will be disabled automatically. So you can't use internet traffic bypass and HA mode. Of course, if you say I want to use the internet traffic bypass and the HA mode, why? So let's have a look in the firewall rules. The Peplink router are routers, of course. It's not a firewall, but we have firewall features and really cool firewall features. At first, we can enable the intrusion detection and DDoS prevention. If we enable this, we are safe before the most common features like the XMAS, some port scans, SYN or DDoS. That's really nice. And we can set up the stateful firewall. We have outbound rules, inbound rules, and internal rules. You have to know that PAP-VPN is also seen as an internal firewall rule and not an outbound rule. So you have to know this. Feel free to create the rules as you want. You can do it locally on the GUI, or you can do it over InControl. You can also set all configurations locally on one router, export the complete configuration, import the configuration in InControl, and use the firewall config from a local device in InControl to bring this firewall configuration out of every device you need it. You can set complete domains in the destination. You can filter IP addresses, domains, or kind of traffic for the firewall. You can also enable the deep packet inspection and use files from the deep packet inspection for the firewall rules. Also for the outbound policies, by the way. And you can also log this firewall rules. And then you can see it in the event logs. It's also nice to monitor what happens on your device if you use any outbound policy, outbound firewall rule, any allow, but with active logging. Then you can see everything what's going through this router in the event log. That's really nice to troubleshoot something. On this page, I missed a little bit from the InControl firewall rules. As I said, we can use InControl also to set the firewall rules. If we use InControl to do that, then we can also set country-based firewalling. Yeah, and this has to be on the slide in my eyes. So you can set country-based firewall rules. E.g., you say, okay, the Germans are not my friends tomorrow. Then I can block every traffic from Germany or to Germany, for example. Then I cannot connect to you with my IP address, with my German IP address. Of course, if I'm a Peplink user and I build up a VPN tunnel like SpeedFusion Cloud to Australia, then I can connect to you, of course. But in the normal way, not. We have some quality of service features. This allows you to control traffic based on user groups. I think this is created from Peplink for the maritime area. You can see it on the names. It means the group names are manager, staff, and guest. So you can apply different bandwidth and traffic prioritization policies on each user group in the bandwidth control and application sections. In this scenario, we have implemented an IP telephony system on the branch office, and we have deployed an IP telephone server on reside the headquarter. To optimize the voice quality over the internet links, QoS is essential for ensuring that the VoIP traffic can be smoothly delivered across the sites. So we go to network, QoS, user groups. Under the quality of service, either clicking on existing subnet or add button, create a new subnet IP range, and from the group down, selected the desired group manager, staff, or guest, and then click on save, and that's it. To enable it on application, go to network application QoS, click add button, and then you can select the category. In this example, it's VoIP, also ported VoIP protocols. You can set the priority here to high, save it, and then all VoIP traffic is set to high. You have multiple features. As you can see here in the blocking section, you can block it or you can prioritize it. You can select Skype or VNC, BitTorrent, and something else also for the QoS, but you also can block this. It's also a QoS application blocking. Then you can deny some services like Skype. You have a lot of pre-installed features or tools or kind of applications you want to block. Thank you, Peplink, for this cool feature. I love it really much. So you can select the application like audio video streaming. You can, if you select the headline in bold written, everything or all supported streaming application, everything what's written under this will be blocked. But you also can say, okay, I don't want to block out all of that. Maybe in the database, I only want to block MySQL. Then you can block that. Yeah? You can select everything in detail what you want to do. And it's a really cool feature and works really easy. Also, you have the web filtering blacklists. You can select the categories like dating or drugs or maybe gaming sites, and this will be blocked automatically. And you can customize some other domains what should be blocked. Maybe you don't like the company is doing the same than you, then block them and you can't reach the website of them. You can exclude the domains. Maybe sometimes a website is shown as a gaming website, for example, and you have blocked it, but it's not a gaming website and you need it, then you can exclude this domain and it will work again. Or you can exclude some users that you say, okay, the normal guests and staff are not allowed to use it, but the managers are allowed to use that. Then you can set it, or you can exclude some subnets. So the bandwidth control from the QoS setting is also easy. As we have seen in front, we can select manager, staff, and guest. These values are all the values we have set in the WAN settings. If we have a smaller bandwidth on the WAN line, we can enter that. And in this example, these are the standard settings with gigabit. If we only have maybe 100 megabit, we have to set it to 100 megabit. Then the 60 would be 60 meg, and the 20% are 20 megs. And then we can put the slides to the left or to the right to make it more or less bandwidth on the different WAN lines for the different user groups. The different user groups are directly connected to different VLANs. Yes, no, the SAS application traffic steering is normally also in the local guy available. You have to enable the deep packet inspection over InControl. Yeah, in InControl you can enable the deep packet inspection, but it could be possible that it's only available on the InControl side because it's a lot of computer power in the background needed, and we don't want to make the Peplink router going slow. That was a question written in the Q&A. So next important thing is enabling IPsec and NAT-T. Normally you don't need it, but if you have a customer who's using an old IPsec tunnel, but this IPsec tunnel is insecure and always crashes, for example, we have it a lot of times with big customers, then they want to set up a SpeedFusion tunnel, but the admins are like dinosaurs. They don't trust the new things. So, especially in Germany, then they set up a SpeedFusion tunnel, and over the through the SpeedFusion tunnel, they will go with their IPsec traffic. Okay, it's possible, but maybe you have to enable the IPsec NAT-T. So if you have, especially if you have the IPsec on the notebooks sometimes, yeah, then you need it. What is it? It's a service pass-through support in the balance router, and by default the router has enabled IPsec NAT-T. If the IPsec is running on custom ports, then you can define these ports accordingly. So go to Network, Service Pass-Through, MISC settings, and enable the checkbox under IPsec NAT-T. Check the define box if running custom ports and fill in the ports you have. Pass through for other services, e.g. SIP, H323, FTP, TFTP can be enabled in this page as well. SMTP forwarding could also be enabled. There are situations where the ISPs will block SMTP forwarding from different ISPs. Thus, the Peplink router allows you to control the right ISP link to forward you SMTP service. This happens if you have multiple service providers because you want to be always online, then sometimes this can be happen. When this option is enabled, all outgoing SMTP connections destined for any host at TCP port 25 will be intercepted. These connections will then be redirected to a specified SMTP server at a port number. SMTP server settings for each one can be specified after selecting enabled. So network settings, service forwarding, MISC settings, you will find the SMTP forwarding. When this option is enabled, all outgoing DNS lookups will be intercepted and redirected to the built-in DNS name server. If any LAN devices using DNS name servers of a WAN connection, like 888 Google or something else, you may want to enable this option to enhance the DNS availability without modifying the DNS server settings of the clients. The built-in DNS name server will be distribute DNS lookups and corresponding DNS servers of all available WAN connections. In this case, DNS service will not be interrupted even if any WAN connection is down. Yeah, these are the icons you can set, also the DNS forwarding setup. As I said, it's a really, really cool feature, also the web proxy forwarding setup. So feel free and always click on the question mark if you don't know what this feature means. And this is really important to have a look on every question mark before you do your test, by the way, that you can find everything. The admin security page, yeah, nice to have, nice to know. You can set the admin password, you can set the user password here. You can set the security if HTTP or HTTPS is only allowed. Is it allowed to access from the WAN or from the LAN side? What are the admin ports I will use? That's important. And you can also enable the authentication by radius. If you enable it by radius, then the users will be authenticated over your radius server. In the log files of the Peplink, they will show as admin. The local admin and the local user accounts will be disabled then. So when the device is not able to communicate with the external radius server, local accounts will be enabled again for emergency access. So it's not like closing the door and throwing the key away. If your radius goes down, the local admin will be re-enabled. You can also set the admin passwords over InControl. That's really nice if you set random passwords, for example, or if you can set different passwords on many routers in one step. Then you can use it over InControl, and also you can see the passwords there. That's nice if you have maybe 30 or 100 Peplink routers. It's hard to change the admin passwords every 3 months. So some of the settings are crucial to the operation, e.g. InControl, remote assistance, and email notification. InControl cloud management. When this checkbox is checked, the device status of information, data usage, and configuration will be sent to Peplink's InControl system. You can sign up there at incontrol.peplink.com. You can register devices under your account, monitor device status, usage, reports, and as well, you can download the backup configuration files there. It's by default enabled. And for the email notification, this feature allows you to send emails to some recipients when the following events take place. You can do the notification test. You can say send a mail when a new firmware is available, when the health status changed for any WAN connection, VPN status changes, bandwidth usage has reached 75 or 95%. So you can enable this mail settings as well. For the remote assistance, if you have some issues or you don't know how to do something, then you can open a Peplink ticket. If you open a Peplink ticket, I will show you later the details, then please download the diagnostic report you see on this link, enable remote assistant, open a ticket at Peplink, and give them the information that you have remote assistant enabled and send them the diagnostic report. If remote assistant is enabled, you will see it on the system information window that is on, and you cannot select turn on it again. So as PCE, as Peplink certified engineer, you are a network specialist, hopefully. Then you also can have a look on this hidden page. Normally, if you are on the local guy, you see the index CGI on the end of the link in the browser. If you change index through support CGI, you will enter a hidden page. In this hidden page, you can set a lot of stuff what is not possible on the main page. It's like a layer 8 prevention, or you can destroy a lot of things, but you also can turn on the remote assistance, and you see the remote assistance status here if it's off or if it's on. So it's a second way to turn it on. So now I talked about 2 hours. If you have questions, I think Stone has answered a lot of them. I have seen a lot of them in the Q&A board, but now I can read a little bit of this and give you also some answers, or Stone can answer the other questions.
Okay, thank you very much for Dennis helping us to talk about the PCE. Actually, we got over 50 questions and then we answer a lot. So what we will do next is, today what we have answered the questions, Cecilia is my teammate, will make a forum post at the Peplink from peplink.com and list out all the questions and answer. Then if you still cannot find the answer you want, then please left your questions there, then we can follow up on the next webinar. So then this will help us to continue the session number 2 in next Wednesday. So thank you in advance that we will see you again. Thank you. Yeah, please give a big thank you to Dennis. We can type it in the chat. Yeah, thank you.
It's a pleasure. And you haven't seen me. You have only seen the slides. So
so thanks for your help today. And then so next week we will have the session number 2. We will go through another set of the materials. And Cecilia will help to send out an email to tomorrow or day after tomorrow. It's about the slide and the recording today. And then we will also arrange a forum post on what we have answered or asked it. Then in session 2, we will go for other content. In end of the session 2, we will send out a mini mock exam. For mini mock exam, then you can try to test for your understanding. If you cannot find some answer or you do not understand that, our other teammates will help on to explain the answer there. So this will be the whole course of the PCE. But of course, if you still have any things you don't familiar or understand, please feel free to ask, and we will try our best to tell you what is going on. Thanks for your time today. Again, see you next week. Thank you very much. Have a nice day. Yep.
Have a nice day.
Bye-bye.
Bye.